Hello again. In this video we're going to talk about a special type of function, namely or a special type of equation, namely quadratic equations. Well, what is a quadratic equation? Well, in the previous unit you've been learning about linear functions or linear equations. They were equations of the type y equals kx plus m, and the graph to these type of functions was a straight line. Whereas in this unit we're going to talk about nonlinear functions, and the quadratic is a type of nonlinear function. And they take the form y equals a times x squared plus bx plus c, where a and b and c are constants and a is not equal to 0. Then we're just back to a linear function. And graphs of these functions look like this. And the various values of a, b and c define the properties of the graph. And what are we actually doing when we're solving an equation like this? Well, for example, if I put the whole of this equal to 0, if I had, say, 0 equals 2x plus 2, then the solution of that equation tells me where the line goes through the x-axis. And if I want to find the solution to this equation, for example, 0 equals, let's see, x squared minus x plus 1, then the solutions would be where the graph passes through the x-axis. And you can see the difference between a linear equation and a quadratic equation is that you can have two solutions, two places where the graph goes through the x-axis. So let's try solving some simple quadratic equations. So let's start with this equation. X squared equals 225. Now this is a quadratic equation because it involves something to do with x squared. That's the meaning of a quadratic equation, and it's x squared equal to some number here. So we want to find the solution or the roots to this equation. Now what do we do to get rid of the x squared, or to find the solutions of the equation? Well, we take the square root of both sides. Because if I take the square root of x squared, I find x, and if I take the square root of 225, well, 225 is a positive number, so if I take the square root, I get two solutions, the positive and the negative solution. So that's an important thing, is that you can have two solutions for quadratics. So on the left hand side I just have x now, and on the right hand side I have the square root of 225, which is 15. but either positive or negative 15, because 15 times 15 makes 225, but minus 15 times minus 15 also makes 225. So in maths, you can show this way. The first one of the solutions is 15, x1, that means one of the solutions, and the other solution is the negative of that value. And you write this x with a subscript 1 and x with a subscript 2. So that's when you have x squared equal to some number, you can just take the square root of both sides, and then you have one solution is the positive value and the other one is the negative value. In the second example, I have 2x squared equals 40. So I have to do a bit of rearranging first in order to get x squared equals. So I have to divide both sides by 2. Then I will get x squared equals 20. 40 divided by 2 is 20. And then I take the square roots of both sides to get x equals plus or minus the square root of 20. So the exact value is x1 equals square root of 20 and x2 equals minus the square root of 20. Now let's see what happens if we plug that into our calculator. To take the square root of something, I press second and then x squared, and then type in 20, enter, and I get a decimal number, 4.47. to 2 dp, 2 decimal places. So either we can say the first solution is positive the square root of 20 and the second solution is negative the square root of 20, or I can say x1, the first solution is 4.47 and the second solution is negative 4.47. Let's do 2 more examples. And let's look at this example. X squared plus 10 equals 6. So I have to get x squared on its own to start with. In this case, I don't have any x's. We're going to come on to how we deal with that in the next example. So I can move over the positive 10 to the right hand side and I get x squared equals minus 4. 6 minus 10 is minus 4. Now at the moment we don't have any tools for solving this type of equation because you know from before that you can't take the square root of a negative number. So at this point we just have to answer that the equation does not have any real solutions. Later on in the chapter, you're going to learn about something called complex numbers, and this actually has solutions in the complex number system. But for now, we're going to leave that one. Now, in the last example, I have x squared plus 4x equals 0. Now, it would be incorrect for us to do this. X squared equals negative 4x, and then just cancel one of the x's on either side. That's the incorrect way to go about solving this solution. What we have to do instead is we have to factorize. So let's start again with x squared plus 4x equals 0. Now, what is common? What term is common to both x squared and 4x? Well, we have an x in common. Let's take the x outside, put brackets, and what do we have left? Well, we have an x multiplied by x will give me x squared, and then a plus 4. X times by plus 4 gives me plus 4x. So I've now factorized this expression into x times x plus 4 equals 0. Now, if we use something called the null product method, the null product method says that if we have two numbers, a times b equals 0, then either all of a can be equal to 0, or all of b can be equal to 0, because 0 times a number is 0, or a number times 0 is 0. So from the null product method, we can say that the first term here, x, is like a, so either x can be 0, so that's our first solution, so we call that x1. x1 can be 0, or all of this thing can be 0. X plus 4 equals 0, and call this the second solution. So we can't write an answer x2 plus 4 equals 0. That's not the solution. The solution, by moving the 4 over to the other side, is that x2 equals minus 4. So the roots, or the solution of this equation, are that x can either equal 0 or it can equal minus 4. If we'd have done it by this method, where I just moved over the 4x to the other side and then cancelled one of the x's, I would have got the wrong solution. So you cannot just do this method. You have to factorize and then use the null product method.